For question number 6, I asked you guys to make an observation, get some letters, and get some numbers associated with it. So here is the parent function, and here is the child function. The child function is going to look like the parent function, but there's some transformations. Class, this -2, where is it? Is it in the inside of the parentheses or the outside?
Inside.
It's on the inside. Is it to the left of the x or to the right of the x? So my b value is -2. Raise your hand if you saw -2. Okay. So we have a letter. We've got a number. Now we need to create a rule. So if I look on my formula sheet, the b value affects which one? The x or the y?
X.
The x. So I'm going to put in the b value. 1 divided by -2. Positive divided by negative is a negative. So the rule that I'm creating is -1/2 times x, comma y. Now let me show you not a shortcut, but a different angle on fractions, because this can be intimidating for students. And I think I drew that silly line the other day. You guys remember that? How my life changed in high school math? You guys remember the O? You guys remember that? Alright, say it now.
Oh.
Thanks, Tom. What does that mean? The x is in the numerator, the top portion of the fraction. What's another way of writing this? -x divided by 2. So this might be super helpful for you as we get new coordinates. Well, what does this mean? Class, does anything change on my y-coordinates? No. So the y-coordinate from the parent to the child is the same. Let's just copy down those numbers. 0, 1, 16. But for the x values, I'm going to have to take these x values and transform it using -x divided by 2. Let's do that together, class. If I put in 0, class, what's 0 divided by 2? And the opposite of 0? 0. Remember, 0 is not positive nor negative. Now let's do 1. Class, 1 divided by 2. Opposite of positive 1/2. -1/2. Let's try 2. Class, 2 divided by 2. Opposite of 1. -1. Alright, we already have the parent function, but I just want to remind you how they got the other points. So this is 0, 0, and of course 1, 1, and 2, 16. But if we think about it, this is an even degree polynomial. That 4 is an even number. It should start up, end up. Therefore, my proposal is that, well, if I know it starts up, ends up, we're going to guess that the symmetry, the other 2 points, are reflected over the y-axis, reflected evenly. What does that mean? There's 2 ways of thinking about it. Here's one way. This is an easier problem. Instead of going right 1, up 1, you can go what? Left 1, up 1. Instead of going right 2, up 16, how would you get there? Left 2, up 16. So that's one way of thinking about it. Here's another way. I'm not sure I taught you guys this one. If your reflection line is the y-axis, everyone say count. You just count towards the line. 1, 2, 1, 2. 1, count past the line. 1. Okay? So that is a review of graphing the reference points. There's only 3, the right ones, then using symmetry. Let's go ahead and graph now the m of x, the child function. I'm sorry, t of x. So this is going to be t of x. I'm going to graph these 3 points. 0, 0. Negative 1/2, 1. So I'm going to go left. Common mistake for students is to think the number is between 1 and 2. Class, what's 1/2 of a dollar? 50 cents. So negative 50 cents, negative 0.5. And then go up 1. Left 1, up 16. Okay, now we need symmetry. So I got 3 points. 1, 2, 3. Let's find the other 2 points. Instead of going left 1/2, where do I go, class? Right 1/2. Now what? Up 1. Instead of going negative 1 or left 1, you're going to go right 1, up 16. Class, what does the new graph t of x look like? What happened to it? Okay, here's a question. Compressed which way? Okay, vertically means that I'm going this way. It's going to be horizontal. So look at your b value. Negative 2. Notice how it is reflected over the y-axis. Okay, and it's basically being compressed because it's bigger. You put in negative 2 here and you take the absolute value, which is 2. 2 is greater than 1, so it's being compressed horizontally. Here's my analogy. Pretend you're walking to your next class with 2 football players, and you're in between them, and they decided to do what? They tried to squish you. Your graph is becoming skinnier, and there you have an example of horizontal compression.